Hello everyone, welcome back to our channel. In today's video, we will be diving into the design consideration of Combined Piled Raft Foundation as per IS 19117 2025. If you are new here, I highly recommend checking out our previous video where we covered the introduction to IS 1911 2025. You can find the link in the description below. Don't miss it for a seamless learning experience. So let's jump in right into today's topic. In this video, I will be explaining general design consideration, stages of CPRF design, design steps to be covered, allowable settlement for static design, proof of design and construction of a CPRF, and monitoring of a CPRF. So make sure you stick around till the end to get a comprehensive understanding of all the essential aspects of CPRF design. In general design consideration, what are the considerations we need to consider while we are going into design? Fluctuations in water table and long-term stability. Why? The reason here is the fluctuations in water table will impact the bearing capacity and settlement behavior over the time. The long-term stability of the bearing strata must be evaluated, especially for compressible or sensitive layers. The next thing we need to consider here is handling sensitive clays and loose-bearing soils. Why? Why to give more caution a lot to the sensitive clays and loose bearing soils because it causes consolidation, strength loss, which could cause excessive settlement or bearing failure. Measures such as ground improvement or deeper piles may necessary. For example, take this image, which is generated by using AI. This is our earth data, and assume it is a clay, sensitive clay. And somewhere here is my water table. So what happens if due to improper geotechnical investigation, if some people is going to place the pile for 10 meter. Assume this is going to be a 10 meter where I'm going to construct my combined pile raft foundation, and the pile is getting rested over the sensitive clay. Assume this is going to be 10 meter. So what happens now? Over the time period, it gets settled. It gets settled, and a deformation will take place. And a deformation will take place, which will be in this form. My pile foundation will get tilted like this. So this kind of excessive settlement may occur when we haven't done a proper geotechnical investigation and we have been placing the pile over the sensitive clay. So to avoid these kind of things, to avoid these kind of accidents, there should be a proper handling of sensitive clay and loose bearing soil strata. The next consideration we need to consider here is effects of soil excavation. Effects of soil excavation is the next issue when we are excavating a soil where for foundation excavation around the foundation excavation around the foundation can cause stress relief and potential lead to lateral soil movements or instability. It's important to account for these effects during design, especially in urban areas or where adjacent structures are present. What does it mean? Which is, just assume that this is my ground and I am making a deep excavation to place my foundation for my foundation, and assume there is a structure which is placed over here. What happens when you are removing a soil? As you have been removed a soil which from this portion from the ground, which is going to create a stress relief. So in previously it has been in the confined stage. Now it is in now what happened is when we are excavating a soil to construct a foundation, a stress relief effect will be taking place. Stress relief effect will be taking place and potentially leads to soil lateral movements and instability. So these all things to be considered while we are designing for CPRF and when we are going to construct a CPRF foundation. The next consideration what we have to consider is load carrying capacity of the combined system. CPRF system must handle vertical loads, lateral forces, and overturning moments at a desirable settlement levels. Proper analysis of raft pile interaction is essential. Is essential. The reason here is the interaction between the raft and the piles must be analyzed to distribute the loads effectively, which means the raft and pile, the interaction between the raft and pile and then to the ground, it should be analyzed to distribute the load effectively and effectively and ensure stability under all load combinations. The next consideration is maximum settlement. The total maximum settlement should not be exceed should not be exceed as per IS code limits. Typically around 50 mm will be taken, but this may vary based on the structure, sensitivity, and serviceability. The next consideration is a differential settlement. Differential settlement. Limit the differential settlement to 1 by 500 of the span to prevent structural damage to prevent structural damage and uniform performance and to ensure uniform performance. Before going into the next topic, I would like to say I would like to discuss some other points of consideration in aspect to structural design point of view. Structural design of CPRF point of view. To design raft, we need moment and shear force, which means the design of the raft involves the calculating the moments and shears based on the applied loads on the soil pressure. This ensures the raft has a sufficient flexural and shear capacity to resist the imposed action. Flexural and shear capacity to resist the imposed action. The next design we need to the next design here is for pile. For pile, similarly, the design of the piles includes calculating the pile axial loads, the lateral loads, and moments. This involves the considering the pile group effects, soil pile interaction, and the transfer of loads between the raft and the piles. The interaction between the raft and piles should be carefully modeled to distribute the loads efficiently and maintain structural integrity. Let's now move on to the three main stages of CPRF design. The first most stage is feasibility study. Feasibility study, where where we will be to where the performance of the performance of sorry, just a minute. Yeah, the performance of we will be evaluating the raft performance without piles and bearing capacity uh, uh, and settlements are checked for the raft. What does it mean? In the initial stages, we assess the performance of the raft foundation alone without piles. This includes the estimating the vertical and lateral bearing capacity and settlements of the raft would experience on its own. Based on this assessment, we determine whether a piled raft foundation is feasible for the project site or not. We also estimate how many piles would be required to decide uh, to decide the to decide to decide um, how many piles yeah how many piles is required to uh, to design as per the design requirements considered considering the factors like load bearing capacity and settlement control. The next stage here is preliminary design stage. Once the feasibility study is established, we proceeded to the preliminary design. Here, the focus is on designing the piles for the combined resistance. This means the piles are not designed to carry the entire structural load, but rather to share the load with the raft, optimizing both structural performance and cost. The final detailed design stage, here we will be finalizing the number, layout, and pile configurations, and also we will be conforming with the settlements, moments, shear forces, and compliance with all design requirements. In the detailed calculations are performed to ensure that the combined system meets both structural and geotechnical design requirements under all loading conditions. In summary, these three stages, feasibility study, preliminary design, and final detailed design, form the backbone of a well-planned CPRF system that balances performance, cost, and safety. Let us now jump into next topic, which is design steps. In step number one, we will be calculating the ultimate pile capacity. By start by calculating the ultimate load capacity of piles using the pile formulas in accordance with IS 2911. This course provides the methodology and a methodology for determining the pile capacity based on soil conditions, pile type, and installation method. And in step 2, the allowable pile load is calculated. How? In step 2, we will be determining the to determine the allowable pile load corresponding to a particular settlement. We will be conducting a pile load test as per IS 2911 Part 4. IS 2911 Part 4. The load settlement curve, yeah, yeah, the load settlement curve from this test is then interpreted by a geotechnical engineer to establish the safe load and settlement behavior of the piles. These pile loads and the corresponding moments are essential for the structural design of the piles. In step 3, the stability and capacity of the raft is calculated. How? Assess the stability and capacity of the raft foundation based on the ground parameters following the guidelines of IS 6403 and IS 2950 Part 1. This course provides a method for evaluating bearing capacity and settlements for raft foundation, taking into account soil strength, compressibility, and loading conditions. In step 4, the structural design of raft is calculating the bending moment and shear force acting on the raft due to the applied loads and the soil pressure due to the applied loads and the soil pressures. These values are used in the structural design of the raft by ensuring it can safely resist all imposed actions and provide the required required performance, which is nothing but a safe performance. In summary, I would like to uh, note you guys that these codes were in starting we will be calculating the pile capacity by using IS code 12911, and allowable pile load will be calculated in the field as per by doing this pile load test as per IS 2911 Part 4, and then draft stability and capacity will be evaluated by using accordance with IS 6403 and IS 2950 Part 1. Then we will be going for the structural design where we will be calculating the bending moments and shear force for the safe performance. Now let's talk about the design philosophies of CPRF as per IS 1911 2025. Here, there are three approaches. One is conventional approach, second is settlement control approach, and third one is creep piling approach. In conventional approach, piles are designed to carry the full structural load, with where piles will be taking the major load and raft will be taking the minor load. This is how it is designed. This is how it is designed in this approach. In this approach, in conventional approach, which is nothing but in this approach, the piles are designed to carry the full structural loads, with the raft mainly providing the construction convenience or minor contributions. This means the effect of raft won't play a major role in conventional approach at all. In settlement control approach, here, the design is governed by limiting the settlement within the acceptable limits in line with serviceability requirements, which means the pile settlement of the pile is approximately equal to the settlement of the raft. This is how the design will leads this design will be done, which is nothing but the piles and raft. The piles and the raft work together to control both total and differential settlements. This approach is generally used. This approach is generally used in CPRF design. CPRF design as it optimizes. Why to use this approach? Why can't we use this conventional approach and creep piling approach? Because it optimizes the bearing capacity. It optimizes the bearing capacity and settlement control and settlement control, ensuring long-term performance of the foundation system. The last approach here is creep piling approach. This philosophy is applied in soft ground conditions where creep can occur. It is used where soft ground is encountered. Soft ground is there. Piles are designed where piles are designed to take care of greater share of the load, where the piles are designed to take care of the greater share of the load over the time as the soil compresses and loses the stiffness. So at the end, for CPRF, the design generally follows the settlement approach, as I said before. Settlement approach, settlement control approach to meet the serviceability requirements. This ensures that the foundation performs well over the structure's lifespans by controlling settlements. Now, let's get into the load carrying capacity of CPRF systems. The ultimate vertical capacity of CPRF system is determined by considering the combined contribution of both the raft and the piles, as well as the interaction between them. According to the standard, the ultimate capacity QCPRF is taken as the least of these three criteria. The first one here is block capacity. Block capacity, where you can see ultimate capacity of the CPRF is equal to Q block plus Q raft outside. What does it mean? What is Q block? Q block is the capacity of the block containing the pile groups, and Q raft outside is the capacity of the portion of the raft located outside the piles pile groups periphery. What does it mean? What does it mean? I will show a diagrammatic explanation. I will remove this and I will draw a what is block, which is nothing but this is my pile foundation, combined pile foundation. This is my ground, and this is the block where it contains a pile group. That means the ultimate capacity of the block. This is the block containing the pile groups is calculated, and the raft outside, this is the raft outside, the portion of the pile group periphery. So this both is get calculated and summed up. In next stage, in the next formula, in the next criteria is sum of raft sum of raft and pile capacity, sum of raft and pile capacity, which is equal to QCPRF is equal to 0.8 into Q unpiled raft plus Q of piled group. What does it mean? Now, in the color, this Q unpiled raft is nothing but a capacity of the raft alone. Capacity of raft alone, as per IS 6403. As per 6403. And this pile group capacity is nothing but capacity of all piles, all piles as per 2911. As per 2911. The next consideration here is criteria here is considering pile raft interaction. Initially, we have been not considering, I mean, like in previous two formulas, in previously we haven't considered any pile raft interaction, but in this last criteria, we've been considering the pile raft interaction, where alpha PR, alpha PP, and alpha RP, which is nothing but alpha PR is interaction between pile and raft, pile and raft, pile and raft, and PP is pile to pile interaction, and RP is raft to pile interaction. In same way, capacity of the single pile is getting is calculated as per 2911, and unpiled raft is nothing but a capacity of raft alone is calculated as per IS 6403. So this, what about these interaction factors? Where these interaction factors alpha PP, alpha RP, alpha PR from detailed analyses or literatures for accurate load sharing behavior is taken from the literatures or the detailed analysis. So now there are some there are some dimensionless factors which has been mentioned in IS 19117 2025. What are they? The first one is pile slenderness ratio, where LP by DP, where LP is nothing but a length of the pile, the ratio of length of the pile to diameter of the pile should range between 10 to 100. The same way, pile spacing ratio should range between 2.5 to 8. Pile soil stiffness ratio should be range between 100 to 10,000. And the raft plan aspects ratio should range between 1 to 10. And raft soil stiffness should vary between 0.001 to 10, which we can find this table from IS 1911 2025. Now, let's discuss about the allowable settlement of static design. Static design. For combined pile raft foundation system, the total settlement under gravity should generally be restricted to 1 to 5 mm. where it should not be the total settlement should not be more than or equal should be equal or sorry should be less or equal to 125 mm. In same way, the maximum angular distortion should also be less or equal to 1 by 500. And also there are four angular distortion uh, um, for angular distortion, which is theta uh, uh, theta 1L, theta 2L, theta 1B, theta 2B, which these denotions, these angular distortions has been discussed in the previous video. Please, if you haven't seen that, kindly look into that to understand what are those things. What is theta 1L, theta 2L, what is theta 1B, and what is theta 2B. And the maximum angular distortion is taken from the maximum of these four, and will be compared with 1 by 500. It should not be more than maximum of these four angular distortion should not be more or equal should not be more than 1 by 500. So So, the final settlement should satisfy the serviceability and maintains the load sharing in the CPRF. However, it is important to note that the total settlement under the gravity is generally used as a guide value. The final permissible settlement should be decided based on the serviceability and serviceability and the need to maintain the load sharing mechanism between the raft and the piles in the CPRF system. Now let's move to the important aspects of proof of design and construction of a CPRF, where a qualified geotechnical engineer expert should review the soil investigation report and selects the input parameters and evaluate the computational model with independent checks and assess impact on adjacent structures and examine the field monitoring plans and uh, acceptance protocols. So, what is monitoring of a CPRF? What we will be doing in monitoring of a CPRF? Continuous monitoring covers that geotechnical and geodetic measurements, new and adjacent structures, and contact pressures at raft, axial pile load, raft settlement, groundwater table, pore pressure, and observational methods during and after construction. What does it mean? What does it mean? Why we need this monitoring? Why we need this monitoring? Whether it is very important? Yes, it is very important to monitor the building, the structure, to adjacent to the excavation and our CPRF system and our CPRF system. The reason here is we to avoid accidents in the future. So what happens exactly uh, if we haven't uh, if we are doing this monitoring, where to place the monitoring? We will be placing the monitoring systems like geophones, settlement markers will be placed on the ground surface, and also for example, I will show you that this is my combined pile raft foundation. Sorry, I'll draw it. Combined pile raft foundation has been constructed here, and over this one, my superstructure is constructed. So what happens? We will be filling this with soil. So we will be placing a settlement marker here and will be monitored during and post construction. During and post construction to make sure that there is no any excessive settlement is taking place due to the excavation or due to the overload of the superstructure. And it may this monitoring ensures that model and design verifications and earlier detection of critical issues to avoid the accidents and quality assurance and load distribution insights. In this we can easily observe whether the distribution of the load is uniform or uneven between them. So So, the monitoring plans should include instrumentation layout like plans and sectional views and be prepared by geotechnical experts like us. So, the next thing here we need to speak about is structural design of CPRF, where in structural design it follows IS 456, IS 456 and other codes for load effects, shrinkage, creep, temperature effects, and reinforcement and detailing. The next thing we need to consider is seismic design. Address the seismicity addresses the seismicity and inertia and key and kinematical effects and follows the relevant IS standards, Indian standards, and it will be designed according to it and should be handled by the experts in geotechnical and structural engineering. At the end of the topic, our this comprises that this comprise uh, it comprises all the design criterias of CPRF as mentioned in IS 1911 2025. Now let's summarize the key points and the practical tips. Initially, we have seen that understanding the site conditions like groundwater table fluctuations, compressible soils, and excavation effects, and apply the settlement control approach for CPRF. Then involve the qualified geotechnical experts for investigations, model verification, supervision, and monitoring. Use detailed instrumentation to monitor settlement and soil pile raft interaction and ensure the structural design compiles with the IS 456 and then design for seismic conditions for inertia and the kinematical effects and perform the independent calculation to verify computational model. So computational models and ensures the design reliability. So that wraps up today's video. Today's video on design consideration for CPRF as per IS 1911 2000 IS 19117 2025. If you found this video is useful, don't forget to like, subscribe, and hit the notification bell so you don't miss our upcoming interesting content. Drop a comment below if you want to meet to me to cover IS 2911 and IS 6403 in detail. I will be happy to create a dedicated videos on those. Stay tuned, guys, for more practical insights on geotechnical and structural engineering. See you in the next video, and thank you for watching and supporting the Geospan channel. Your curiosity drives our exploration beneath the surface. Thank you once again.